and welcome to your technique video for the Physical Properties and Concentration Lab. As always, whenever chemicals are going to be out, your goggles need to be on. The solutions that we're working with this week are pretty mild, about as dangerous as your grandma's sweet tea, so if you spill it on your skin, all you need to do is flush it with water. If you do spill it, make sure you wipe it up, and at the end of the lab period, please use a wet paper towel to wipe down your lab bench completely. Look what happens to our dinosaur friends when they get trapped in your sticky mess. If you don't want to be responsible for the next mass extinction, make sure you clean up any spilled sugar solution. If you take too much reagent, the excess can be poured down the sink, but try not to take too much. Start by priming your pipette by rinsing with water 3 times. Then with the solution 3 times. The water cleans it and the solution rinses out any leftover water that would have had a diluting effect. Draw up the solution by squeezing the bulb and placing it on the pipette. Then remove the bulb and place your finger over the top to the pipette to keep the solution from flowing out. Read the volume at the meniscus as you hold it at eye level and record it to 1 degree of uncertainty. This means that if the pipette is graduated or marked to 1/10 of a milliliter, you will guess what the 100th place would be and report that as the value. After you've written that down, remove your finger and allow some of the solution to flow into your new container. Put your finger over the top again to stop the flow. Read and record the final volume. Determine the volume delivered by subtracting the final volume minus the initial volume. Pour some solution into the graduated cylinder. Read the meniscus at eye level and record the value to 1 degree of uncertainty. Pour an amount of solution into your new container and read the final volume. The math is a little different from the equation used for the pipette. Because the graduations run in the opposite direction, you'll need to do the initial volume minus the final volume. Tare the balance to 0. Because you share the lab with other people, you will tare the balance with nothing on it, then record the mass of the container you are measuring with. That way, other groups can use the balance while you are in between steps. Record all the decimal places that the balance shows in your notebook. The last decimal place will often shift due to environmental factors, so pick the number that it displays the most. Or, if it cycles between a range of numbers, choose one near the average. Pour some of the desired substance from the stock container into a beaker. Then, transfer some of it to your container. Never add a chemical to the container while it is still on the balance pan. Take the mass of the container with the substance and record it. The difference of the 2 masses is the mass of the substance. If you take too much, do not return it to the stock bottle. Put it in a waste container or offer it to another group. Solutions allow us to handle small quantities of solutes in reasonable volumes. A stock solution is a solution that has already been prepared and the concentration is known. Creating a less concentrated solution from the stock solution is known as dilution. The concentration of the new solution must be lesser than that of the original. An easy formula that can be used to determine the new concentration is C1 times V1 equals C2 times V2. C1 is the concentration of the stock solution. V1 is the volume of the stock solution that you're using. Usually, once you transfer a portion of the stock solution to a new container, you will add water or another solvent until it reaches a certain volume. This is V2. Now use algebra to solve for C2, your new concentration. This equation is covered in greater detail in a separate video. You can find this on Canvas. We hope you enjoyed watching this video, and we'll see you next week.